Hello, welcome to Cerebral Lectures, and today we will discuss pyrimidine synthesis. So these are most of the reactions we will discussing for the formation of UMP, which is a pyrimidine nucleotide. The other pyrimidine nucleotides include CMP and TMP. So the first step is the condensation of two molecules of ATP, a carbon dioxide and a glutamine molecule in the presence of carbamoyl phosphate synthetase 2 enzyme to form carbamoyl phosphate. This carbamoyl phosphate is then acted upon by aspartate transcarbamylase enzyme to form carbamoyl aspartate, which is then acted upon by dihydroorotate enzyme to form dihydroorotate. Dihydroorotate is then converted into orotate in the presence of dihydroorotate dehydrogenase enzyme. The hydrogen removed in this reaction are used for the formation of basically in the conversion of FMN into FMNH2. Orotate is then converted into OMP in the presence of orotate phosphoribosyl transferase enzyme. OMP is then converted into UMP in the presence of OMP decarboxylase enzyme. So this was all about the formation of UMP. Now let's have a look at the conversion of UTP into CTP. Nothing to worry about. UTP also comes from UMP. So if we phosphorylate UMP into UDP and then UDP into UTP, we can easily convert this UTP into CTP, which is cytidine triphosphate, in the presence of CTP synthetase enzyme. This reaction also uses glutamine and ATP, and the end product is CTP, which is another pyrimidine nucleotide. The third set of reactions will be dealing with the formation of deoxy-TMP. Deoxy means we remove deoxy means we remove a hydroxyl group. So we can convert CMP into deoxy-CMP by removing a hydroxyl group from CMP. Then we can convert this deoxy-CMP into deoxy-UMP and then deoxy-UMP into deoxy-TMP in the presence of enzyme thymidylate synthase. This reaction also requires the conversion of N5-N10 methylene tetrahydrofolate into dihydrofolate. This dihydrofolate never goes to like garbage. It is then reutilized in our body. It is reduced into tetrahydrofolate in the presence of dihydrofolate reductase enzyme. And now we have two inhibitors of this reaction. First is 5-fluorouracil and then we have methotrexate. 5-fluorouracil inhibits the usage of tetrahydrofolate and its conversion into dihydrofolate. So it will inhibit the enzyme thymidylate synthase by inhibiting the usage of N5-N10 methylene tetrahydrofolate, whereas methotrexate, which is a folic acid analog, as we have discussed it in purine synthesis, it inhibits the enzyme dihydrofolate reductase, which reduces dihydrofolate into tetrahydrofolate, and NADPH is used here as a hydrogen source. So that's all about the formation of TMP, and now we have discussed the formation of all of the three pyrimidine nucleotides, which are UMP, CMP and TMP. We discussed the easiest possible way to form these pyrimidine nucleotides in our body. Okay, let's talk about pyrimidine degradation. Pyrimidine degradation. Just like purines are degraded in our body, pyrimidines are also degraded, but the process is not as complex as it was for purines. CMP and UMP are converted are degraded basically into beta alanine, whereas TMP is degraded into beta amino isobutyric acid. Beta amino isobutyric acid. That's all about pyrimidine degradation. Now, do we have any associated clinical with this process of pyrimidine synthesis? Well, yes. Orotic aciduria is the clinical here. Let's have a look. Now we are back at our first set of reactions, which was for the formation of UMP. Um, Orotate is converted into UMP, and OMP is like a transition in this. The two enzymes involved are orotate phosphoribosyl transferase and OMPD carboxylase. So if there is any kind of malfunctioning with either of these enzymes, orotate will start accumulating in our body, and our body will start excreting orotate in urine, which will lead to orotic aciduria. The name pretty much shows it that it means the appearance of orotic acid in urine. The other two major characteristics present in patients with orotic aciduria are poor growth and megaloblastic anemia. So if a patient presents with megaloblastic anemia, poor growth, and appearance of large amounts of orotate in urine, it means that the patient has orotic aciduria. Administration of uridine to the patient can result in improvement of anemia and decreased excretion of orotate. That's pretty much about pyrimidine synthesis and orotic aciduria. I hope you liked the video, and if you have any suggestions, leave them in the comments section. I will definitely have a look at it, and take care. Bye.